term machine learning was coined by Arthur Samuel in 1959. He said, it gives computers the ability to learn without being explicitly programmed. Machine learning is for sure one of the most powerful technologies in today's world. However, we still didn't see its full potential. There is no doubt that it will continue making the headlines for the near future. In today's broadcast, I'm joined by Saeed Abu Nimeh, the founder and CEO of Seclytics, but after this short introduction video. Saeed, good evening, and thank you very much for joining this session today.
Good evening, Samar, and thanks for having me. Appreciate it.
Great. So, Saeed, we do have a very interesting topic today, machine learning, buzzword, we hear it a lot. So, being an expert in this domain and someone who worked in this field for a long time, can you maybe give us a quick summary about what is really machine learning, and is it really a hard thing for us to learn and use and apply?
Yeah, absolutely. So machine learning is a subtopic in the computer science field that simply focuses on training models on different data sets. Usually, you would like to build a model to distinguish between two sets of classes, either something positive or something negative. And you usually use these models to discriminate between the positive class and the negative class. The simplest example that you can give to anyone is the spam filter engine in your mailbox. Mm-hmm. The underlying technology for this spam engine or spam detection engine is basically machine learning. They use different models there, but the most popular one is called the naive Bayes model. Simply, you bring a data set of good emails and a data set of bad emails, and then or spam emails, and then you train the model on it. In the future, if you receive emails, the model will distinguish between or will discriminate between, is this a good email or a spam email? Is it a legitimate email or a spam email, by trying to match the closest class for the email you sent it. So the question about, is it hard? It's not hard. It is simply based on statistical models that have been developed and used for hundreds of years. What we sometimes really lack in machine learning is data. And I think one of the topics we will talk about today is related to data. So if you have good data, you will build a good model. If you have bad data, the model will not fit whatever you want to feed that model, and it will result in bad results. We usually call it in machine learning overfitting, which is basically you feed your algorithm a piece of information, but what you trained the model on is something that's completely unrelated, and the output will be completely unrelated or completely wrong. So people simplify this by saying garbage in, garbage out. You feed the model bad data, you will get bad outputs.
So Saeed, today we start by the data, and we'll speak about it in more details, but we try to build, as you said, a model, right? So this model today, you build it probably based on equations, algorithms, math, all this information that we already know since many years. So I can have this, understanding of the data around this model and then apply it, right? So I can predict what could be the next output or the future output same on the same data. Is that correct?
Yes, correct. So simply, when you build a model in machine learning, there are two different types of learning. The first one is called supervised learning, and the second is called unsupervised learning. When you talk about supervised learning, basically, you are talking about training a model based on labeled data that you have. So in the spam example, you will have a data set of legitimate emails and a data set of spam emails. The data is labeled. You know what is legitimate and what is spam, and then you train the model on it. Now, in unsupervised learning, usually you do not have labeled data. You rely on separating the data based on certain variables and features, and you generate clusters out of the data. A good example will be if you want to build a model to distinguish between purchasing habits for people around the world. You will end up with clusters for the Middle East, clusters for Europe, clusters for North America. You will notice probably that patterns or buying patterns, buying behaviors for people in certain regions, people will have the same buying patterns. Maybe here in the US, you will see spikes during Thanksgiving, Christmas. In the Middle East, you will see it during Eid al-Fitr, Eid al-Adha. So there are certain things that you can discriminate the data based on, and this is why you use unsupervised learning, simply when you do not have labeled data and you just want to create regions or clusters to separate the data.
Right. And today, applying machine learning or understanding it, does that mean that we understand AI as well at the same time? Because what the definition says, machine learning is a subset of maybe data science, AI. So does that mean if you want to move into the next step and apply artificial intelligence or more techniques, then you need to do more steps or acquire more information?
Yeah, that's absolutely correct. Machine learning is a subtopic of artificial intelligence. Artificial intelligence is a very generalized idea about building robots and building automated processes to do things that human beings do. And then when you talk about machine learning, it's basically a subset of that. So the topic usually focuses on the theory and some implementations or some real use cases that are part of artificial intelligence. Maybe you talk about image processing, or you talk about speech recognition. So it's not only related to building robots and what have you, but you can do other stuff like the two examples I just mentioned. So when you talk about machine learning, if you pick any machine learning book, usually you start by the theoretical underlying algorithms that you can use for any model that you will build. Usually it's a statistical model. And then when you finish these models, you can talk about advanced topics that you can use to leverage artificial intelligence to build robotic machines and to build other more complex systems that will help you achieve other goals as well.
Right. Let me move to the second topic that we just touched on about the data, because it's extremely important, and we can see known people like Bill Gates, and I'm going to share a saying for him, saying, you know, a breakthrough in machine learning would be worth 10 Microsofts. And someone who worked in data all his life, like Bill Gates, understands the importance of machine learning, and data is extremely important, and really gives us all a signal that this is serious, right? And nailing it the right way is very important. So why data is very important for machine learning?
For a simple reason that I mentioned, which people talk about all the time. The concept that people talk about is garbage in, garbage out. So if you train a model on the wrong data or data that is biased, you will have a biased model. And no matter what data you feed it, you will get the wrong output or an output that is not accurate. So if you don't have the right data to train the model, your model will be useless typically. This is one of the problems that we face a lot in certain fields that we lack data. For example, in cybersecurity, in certain automation processes that we build, usually we do not have real data from real customers. So you end up generating synthetic data, which results in a model that is not even close to reality. So when you deploy the model, you will have lots of false positives, lots of false negatives, and then you will take that data that got generated, you will use it to retrain the model, and you will do your best to keep retraining the model to get to a point where the model is giving you accurate results or accurate data, accurate output. So do we have the right data? In some fields, yes, because the fields have been studied for a long time. In some fields, the answer is no, because it's an emerging topic or an emerging subject that people are trying to apply machine learning to. If you look, for example, if you look and study text mining literature, you will see that text mining has been applying machine learning for a long time. They have good data sets, clean data sets. So when it comes to text classification, you will see that algorithms are typically a little bit accurate compared to other data sets or other fields or other topics.
I actually have a very interesting question from Ahmed. I'm sharing it right now. So Ahmed asks, what is the accuracy of this machine learning? Also, what I noticed from different data projects, most of the time the data is not enough to build a decision or reach for a decision. So what do you think about that side?
So again, the accuracy all depends on the model that you are training, right? So if you have good data that you use to train a model, the accuracy of your algorithm will be high, or your model will be high. Take, for example, just as an example, the Gmail spam filter. Lots of people will tell you that the Gmail spam filter is accurate. That's because Google has a very good data set of spam versus ham or legitimate emails. There will be for sure false positives and false negatives, but the accuracy metrics are high compared to other spam filters. Again, why is that? Because if you think about it, we have, or Google has the right data to train the models. Things change with time, so this will result in the need for retraining the models and the need for rebuilding these models. Now, the question about that most projects, the data projects most of the time do not have the data to build or reach a decision. That's correct, because you will need to retrain the model usually to get to an accuracy that you are satisfied with. And if you just build a model, deploy it in production or deploy it live and leave it there, with time the accuracy will decay and you will not get the results that you were getting initially, because things change all the time.
Right. And maybe another question, let's take it since we're talking about the data. So a question from Wahiddin, he's asking, threat hunting tools are great example of machine learning. Do you recommend certain sets of data to be fed to the tool? So today many corporations and many companies provide this service to do the threat hunting, to expose what kind of attacks that could be already inside your environment or network, and try to catch it and deal with it. But looks like these threat hunting tools also need data. So would this data depend on what's there at the customer already, or you can bring external data that would help these threat hunting tools?
Yeah, definitely. So threat hunting is used in cybersecurity to basically investigate, collect, and correlate different data points to reach a decision. So there are lots of APIs that are available and lots of tools that are available that you can get an ensemble of and connect together to reach a decision. Tools like, I'm sure everyone is familiar with, VirusTotal, domain tools. We at Seclytics have also an API that we make available to researchers for free. There are multiple sandboxes that people use as well. One of the most famous ones is the Cuckoo sandbox, sandbox output, which is basically, by sandbox I mean a virtual environment or a bare metal that you can use to run malware samples to extract certain artifacts from that malware sample, be it either PCAPs, TCP data, DNS data, and what have you. So Cuckoo Sandbox is one of the famous open source ones. There are lots of data that can provide you with DNS intelligence, like Farsight or the Risk IQ Passive Total API. There are lots of tools, but mainly these are the 5 or 6 tools that most of the people use these days.
Right. Great comment. So since we're talking already about threat hunting and cybersecurity, so let's move to the next topic about how well the cyber criminals use the machine learning. And allow me first to share an answer from the AI. So we've asked this question to the AI to see what could be the answer. How will cyber criminals really use the machine learning today to probably cause more damage? And the answer was the following. So it says cyber criminals will likely use machine learning in a variety of ways, but I suspect most of these would be for automation. As in the past, cyber criminals are often looking to make their jobs easier and more effective, so they can focus on the higher value tasks like figuring out new scams or doing research and development on newer attacks. So I don't know if you agree first. Do you agree?
Actually, I disagree. That's one of the things they can use it for, but we forgot about the low-hanging fruit, which is defeating existing systems or solutions that have been built leveraging machine learning. So look at, for example, Silence or CrowdStrike or lots of the endpoint protection solutions that have been built leveraging machine learning. Or even there are lots of solutions these days like CyberReason, like most of the firewalls, next-gen firewalls or web gateways today leverage some type of machine learning. So I think cyber criminals, yes, will use machine learning for automation, but actually what they will use machine learning for is to beat the systems that have been put in place, and these systems have been built on machine learning. So there was a very interesting presentation at Black Hat, I think last year or the year before, where researchers showed evidence that cyber criminals are using machine learning to train models to defeat security solutions nowadays. And if you think about it, it's an interesting thing to think about, because when we build systems or when we build models, machine learning models, to detect and discriminate between anomalies, good behavior and bad behavior, we are relying on data. So if the cyber criminal takes the same data and then feeds that data to these systems. So let's say that the cyber criminal purchases the McAfee antivirus and he develops a piece of malware. He finds by testing that malware against McAfee that McAfee detects that malware. Good. The same cyber criminal will go make some changes and then test that again against McAfee. When it's not detected, he will, in a way, if he has a good sample, he will be able to find what features have changed in these malware samples that made McAfee not detect the malware sample. Imagine doing this at a larger scale. Like, I will test it not only on McAfee, I'll test it on all endpoint, all firewalls, all web gateway, and what have you. And then I'll be able to build models to say, okay, this is how these solutions are detecting, and this is how I can defeat that detection by changing these features or these patterns and what have you. So it's something that's very doable, and cyber criminals are doing it today for sure.
And where do they, Saeed, collect the data they need? So definitely, I mean, cyber criminals maybe are they utilizing botnets, for example? Are they bringing data from dark deep web? Are they purchasing it, or is it, or they're leveraging maybe the exposed networks for some, businesses and taking the data outside to train it? So how can they really reach to the results that they want faster? Because definitely they need this data.
They are the ones producing it, right? So, and these cyber criminals talk to each other and they exchange data, they exchange information. So if you go on any underground forum, you will see that people trade samples, people trade stolen credentials, people trade knowledge, and they do this all the time. Well, a simple thing that anyone can do is to set up a honeypot or spam trap or a DNS sinkhole. We use this as threat researchers and security researchers, and I'm sure the bad guys are doing the same thing. So they can set up spam traps, honeypots, DNS sinkholes. They have malware sandboxes. They extract command and control information by running malware. So they do the exact same things that we do in the industry as professionals. Plus, they have another advantage, which is that they know each other and they trade and share information, exchange information amongst each other. So this is something that we don't have the leverage to do. There are companies that have researchers monitoring these forums, yes, but getting trust is always difficult there. So this is something that cyber criminals will have an advantage all the time over security researchers.
Right. So we have actually a comment from Aid Al-Qarta. So Aid says, if the machine learning model has been tried to avoid flagging files to minimize false positives, malware authors can inject clean strings in malicious files to defeat the detection. So this is one of the ways that Aid today is sharing with us, but how the cyber criminals today can leverage the machine learning. So what's your comment on this, Saeed?
So yeah, it's the same thing we talked about. Like, if you look at samples of benign files, right? or even malicious files, you can extract certain features from these files. By features, usually we are looking at things that distinguish your observation or your sample, so you can tell if it's good or bad, if it's positive or negative, if it's spam or not spam, or if it's legitimate or malicious. So you look at these features and you train the model on these features. So as Aid was saying, if I have a good sample or a negative sample that I want to train a model on, I can start introducing certain features into this sample to train the model that the features that I'm introducing are legitimate, and this is what the negative class looks like, or this is what the benign sample looks like. And then my model will start learning that basically with time. So I think this is what he was referring to, that malware authors will take these features that exist in legitimate samples and then train models of malicious files by introducing these benign files to trick the model and show it that this is a legitimate sample or this is a negative class, basically.
Right. And another question from Muhyiddin. So Muhyiddin is commenting here about the resources that we need to apply machine learning and AI. So he's saying they are very resource consuming processes by nature. So do we recommend the cloud hosting or utilizing the cloud for that? Now, for the second question around advising CISOs to comply with the regulations of the cloud, I would suggest, Muhyiddin, if you look at the previous broadcast we had, it was around the cloud in Middle East and Africa, and we spoke about this point about the regulations. So I'll refer you to that broadcast. But let me take the first part with Saeed and ask him, do we even have an option outside the cloud, and when?
Yes, so to answer the question about the cloud, yeah, there are lots of platforms that support this. If you look at AWS, Amazon Cloud Services, or Google Cloud, or even, of course, Microsoft Azure, all of them have offerings there that provide you with libraries that are pre-built to help you with training models, with feature extraction, feature selection, with building models, retraining models. So most of the cloud hosting providers will have offerings, libraries, and tools that you can leverage. Now, if you don't want to go the cloud route and you want to have something on-premise that will do this, people rely a lot these days on GPUs. GPUs help you train huge amounts of data in a very short period of time. And if you just Google GPU setups that people have done in the past to train models, you will see that some people even leverage their old phones and their old laptops by building a cluster of servers that they can use for training. So this is something that lots of people use these days. GPUs tend to be expensive, though. So if you have the funds that can sponsor building something on premise without leveraging any cloud solution, that will be an option for you.
Right. So today we need good data, we need processing and the power, right? And then we need the knowledge to build the model so we can really reach to good results. So
the knowledge is one of the main things that lots of people like. People usually refer to it as we need experts in the field. So when you talk about image processing, you need someone who knows what features should be extracted from these images to build models. When you talk about cybersecurity, you need someone who's knowledgeable in the space, who knows what malicious looks like, what benign traffic looks like. So knowledge is probably more than 50%. If I were to put a weight on it, the weight will be more than 50% to get a successful model built.
Right. And now moving into the industry. So today it's clear that you can apply machine learning in many areas, many industries, many sectors, from healthcare maybe to banking, to many others. In your opinion, Saeed, today, where we can maybe apply this, if I'll think about it maybe from a Middle East and Africa perspective, because if I'll share, the numbers that Statista shows online about the income that we expect from the machine learning or the revenue, you can see now we're into 2020, we're around 250 million, but this will jump to almost 1,500 million. Right, by 2025, and this is only in Middle East and Africa. So definitely, we're seeing a big opportunity here for the different sectors around the Middle East and Africa. So, where do you think this can be applied fast? Because maybe they're ready, and for, in your opinion, which sectors will benefit the most?
Yeah. So excellent question. If you think about what's happening in North America and in Europe, and you try to maybe infer what's going to happen in the Middle East and in North Africa and Africa in general, there has been lots of success here in applying machine learning to image processing. Mm-hmm. If you look about Facebook, if you think about LinkedIn and most of the social networks that exist, they applied machine learning successfully in image processing. If you even just go to any mall here nowadays, instead of using your credit card to pay for parking, they have a system that will scan your license plate. So when you enter and leave, they will know that you entered the mall and left the mall, and they can process your credit card if they have it on file. If they don't have it on file, you can just scan it and get going. So image processing is one of the fields that machine learning has been applied very successfully to. I know we talked about healthcare and the financial sector. Healthcare is a tricky one because of privacy laws. In the US here, we have lots of HIPAA and other regulations. That's why there has been lots of projects that talked about building privacy-aware machine learning models. Basically, how can I take a data set, remove all the PII information from it or personal identifiable information from it, and then use that to train the model. The trick there is to build an accurate model without relying on the private data, right? So in the healthcare industry, there has been lots of advances, but people are still cautious about applying it fully there. In the financial sector, especially if you talk about insurance, if you talk about banking, yeah, machine learning has been applied there for a long time. That's why you see people receiving credit cards offerings all the time. People are seeing fraud detection techniques applied all the time. In insurance, you see when your premiums go up, when certain offerings come to you to reduce your premiums, what is the risk that you have of having an accident or being a reckless driver? Yeah, machine learning has been applied there for a long time. Cybersecurity is one of the rising topics when it comes to applying machine learning. There are lots of startups nowadays, if not all of them, that talk about applying machine learning to cybersecurity. So there has been lots of success there. One of the most famous examples is CrowdStrike, a company that went public recently. They were one of the first companies to leverage machine learning to protect endpoint. And yeah, I think the sky is the limit here. We will see lots of companies, lots of technologies built around machine learning.
Saeed, just on this point, so do you think a collaboration on a sector level on the machine learning is possible? For example, sharing information or sharing models, let's say, is that something feasible and possible between businesses in the same sector? Let's say in the healthcare, a hospital or a group of hospitals in some country that they manage to train a good model to diagnose, I don't know, a cancer or to diagnose other diseases. Do you think these models can be good enough to go and share it with different geographies, different hospitals outside that region, or in machine learning we need to be cautious around that?
Sharing models is easy. I can train a model today and I will send you the object for that model and you can apply it. The problem is that will you get the same results that I did get? So think, for example, that I have a model to detect spam emails in my Gmail today. If I take that model and give it to you, maybe it will cause lots of false positives because my definition of spam is different than yours. Maybe you are interested in receiving recipes about cooking certain cuisines or what have you, but I think this is spam. So I trained my model to block all of these and say that any cooking recipe I receive is spam. To the contrary, you will find that this is an interesting topic to you and you will like to receive these emails. So sharing the model is easy. That's not a problem. The problem is that applying that model to different data sets, yielding different results. So if I give you that model, for example, let's say that we trained the model here to detect or provide us with early warning signs of prostate cancer. Good. We trained the model on a population of old men, 60, 70 years old in Texas. If I take the same model and I give it to a hospital in California, people have different eating habits, people have, the weather here is different, so the variables that I used in training my model in Texas is completely different than the variables I will use here. Sharing the model, yeah, sure, we can share it, but will we get the same results? Most likely not. You need to train it on very specific data that you have. Sometimes even you have to introduce new features that, again, this goes back to the point we talked about being an expert in the field. In the Middle East or here in California, maybe people will think that we should use other features to train the model than the features that we use to train the model in Texas, for example.
Right. So it all boils down again to the data, right? Data is very important and essential in machine learning. So at the end, Saeed, I just want to hear from you. What do you think is the future of machine learning? Do you think it will remain as important as it is now, or there'll be maybe new technologies that will take over as we move forward that we need to be aware of?
Definitely. So I think we haven't seen anything yet in machine learning. There will be lots of improvements, lots of progress in that field, and we will see lots of applications on it. For example, if you think about just the last 10 years, the advances that have happened in deep learning, people thought about training a neural network similar to how the brain works and how neurons are moving in the brain. And they took the same concepts and they built what is called now deep learning models, or deep learning in general. It's an emerging topic. This only just happened in the last couple of years. If you talk to anyone in the 80s or early 90s about neural networks, yeah, they will tell you it had limitations and what have you. But now, like the sky is the limit. I don't think we are even just seeing the tip of the iceberg there. There is lots of improvements that can happen. What will help in all of that is three things. the amount of information we have is increasing. We have lots of information that we are collecting. The processing power, the hardware is getting higher. Processing power is getting higher. Hardware is getting cheaper. So this will all contribute to that. And even just education and knowledge. People are now more educated. There are lots of resources online and in person to learn about these topics. So I think we will definitely see lots of progress and improvement in this area.
This is exciting for me to know that there is a lot still to come in machine learning. I personally love this topic. I think it's one of the best things we're right now, and we're learning about it. Hopefully it will bring many good things for us in the future, more than the downside of machine learning because it's used by cyber criminals. Saeed, thank you so much. It was great to hear from you today. And I would like also to thank everyone who watched us live. Please share with us your notes, comments, suggestions for the next broadcasts. And I'll hope to see you soon. Take care.
Thank you.